Okay, next is question number 16 from the October 2024 Physics Unit 1 paper. Let's see. A simple hydrometer is a cylinder with a mass at one end. Okay, the cylinder floats vertically in a liquid. The diameter of the hydrometer is x. A scale of the side of the diameter shows the vertical position of the hydrometer in the liquid as shown. The scaling on the body of what? Of the hydrometer shows the height, the depth, which is above the liquid surface, which is below the liquid surface. Okay, so a student placed the hydrometer in a sample of pure water. So part A is asking here to complete the free body force diagram below to show the forces acting on a hydrometer when floating in water at equilibrium. Okay, so since the hydrometer it is floating in equilibrium, so in that case definitely the resultant force should be what? 0. So in the vertical dimension, the weight of the hydrometer is acting downward, and upthrust, since it is submerged within the liquid, so upthrust will be acting upward. So both the upthrust and weight will have the same magnitude because the hydrometer it is in equilibrium. So at first what? Weight is acting downward. We'll write this is the weight. Remember, the length of the arrows should be what? Equal, to show that their magnitudes are what? Equal. So upthrust would be of equal length arrow. So this is upthrust. That's it. That's for 2 marks. The free body force diagram of the hydrometer floating in equilibrium. Done. Okay. Next is part B of question number 16. The student placed the hydrometer in a sample of seawater. Seawater is more dense than pure water. Okay. At equilibrium, the vertical position of the hydrometer was higher in the seawater than in the pure water as shown. Okay. So you can see in the figure that in pure water it is submerged at more deeper height, right? And in seawater it is submerged at smaller height. Okay, smaller depth, you can say. So part 1 of B is asking here to explain why the vertical position of the hydrometer was higher in the seawater than in the pure water. Okay, it's for 3 marks. We need to explain why the position of the hydrometer was higher in the seawater than in pure water. Okay, 3 marks. That means we have to consider 3 points in this case. So the first point is what? The density. They said the density of seawater is what? Greater. Okay, since the density of seawater is greater, so we know that upthrust is what? V rho g, right? So that means since rho is greater, upthrust will be greater, right? But here, to keep the hydrometer in equilibrium, weight should be equal to the upthrust, right? So this is the first point. We will consider what? In both liquids, weight of hydrometer should be equal to what? Should be equal to upthrust. Okay, next, second point. So what is upthrust? Upthrust is equals to what? Since upthrust, it has to be equal to the weight. So let's write what's the value for the upthrust. Upthrust is the, you can use formula, no problem. Upthrust is the weight of displaced what displaced fluid, that is what 𝗔-𝗟𝗃, right? V, or give AH-𝗄𝗃, that's better. V is AH-𝗄𝗃. Okay. Upthrust is the weight of displaced fluid. So since upthrust has to be equal to the weight is constant. Weight is constant. And what is constant there? A is constant. Area of cross section, A is constant. Therefore, since the weight is constant, area of cross section is constant. Therefore, in seawater, since it has greater density in seawater, it will need, the hydrometer will need what? Smaller amount of fluid need to displace smaller amount of fluid less amount of fluid to be equal to the weight. Okay, so that's why since rho is greater, therefore weight is constant, right? So H should be smaller. Fine. Amount of fluid to be equal to the weight. So depth of being submerged, depth of immersion, the part of the hydrometer that is submerged, the depth. So depth of immersion will be smaller. Seawater. Fine. These are the 3 points you can write for part B1 of question number 16. Fine. Okay. Next is part B2 of question number 16. So here the question is asking to calculate the change in the vertical position of the hydrometer when moved from pure water into seawater. Okay. So when the hydrometer is moved from pure water to what? Seawater, like what's the change in vertical position? So weight of hydrometer it's given 0.324 Newton. Density of pure water is given 997 kg per meter cube. Density of seawater it's given as 1025 kg per meter cube. And x, the radius of the hydrometer, it is 1.23 centimeter. Okay. So to find out the change in vertical height, at first we need to figure out what was the height of the hydrometer in pure water. So to find out that, we will consider what? AH-𝗄𝗃, right? In pure water, we know that weight should be equal to what? Weight should be equal to upthrust. So we will write A, area of cross section. Okay, let's find out the area of cross section. Okay, let's first write the equation. AH-𝗄𝗃 should be equals to the weight. It is 0.324. That much Newton. Okay. So area of cross section we need to find out pi r squared. So we need to find out the h. Okay. So to find out h, let's take a rho g to the right side. So it will be the denominator. Area of cross section is what? Pi r squared. Okay. So this is the diameter. So we will use pi d square over 4. So that would give you 1.23 over 100, right? 100, because we have to convert it to meter. D square over 4. So 100 times 4 whole squared. This is the area of cross section. And then the density G. Density of pure water is 997 kg per meter cube times G. So the submerged height of the hydrometer in pure water, it is how much? 0.324 over 3.1416 times 1.23 over 400 whole squared, and then times 997 times 9.81. So the height is basically 1.115166504 meter. So that much height will be submerged within the pure water. So now consider in seawater, H would be how much? 0.324 over pi d squared over 4 so this is the area of cross section, and then the density is how much there? 1025. So 1025 G. So that would give you 0.324 over 3.1416 times 1.23 over 400 whole squared times 1025 times 9.81. Okay, so that gives 1.084703419 meter. So we got smaller height. That's fine. We know that in seawater the height, the submerged height, it will be smaller. So del H, change in vertical height, it is how much? 1.1151666504 minus the answer that we found just now, which is 0.03046308528, that much meter. So change in vertical position up to 3 significant figures, we can write 0.0305 meter. That's the answer for part B2 of question number 16. Fine.